September 14th. Quite a few people today. Wanted to turn it over to Keysight this morning unless there was some pressing agenda items that anyone had. So yeah, go ahead, Chris and your team.
Great, thanks. And for anyone who's new, I'm Chris Sommers with Keysight, and we're doing a lot of work on the test framework for Dash. So today, I'm kind of excited because we're going to give the community a sneak preview of a new test framework that we've been working on. And it's still a work in progress, and we wanted to give people a look at this to get reactions and feedback. There's still time to do, course corrections or factor future plans in. And we engaged the services of PLVision for this project. And many of you know PLVision. They're doing other work in this project and in Sonic in general, and a great company to work with. So what I want to do is talk about this new framework, and it's built upon PsiChallenger, which is something that's already in the OCP repo, and PLVision created that and actually announced it about a year ago, and they talked about it at OCP Summit last year. And we're going to build something on top of that and extend it, and I'll go through and explain the rationale and what it offers. And PLVision, Anton will give a mini demo of some work in progress so you guys can get a look at it. And then we'll talk about it and get some feedback. So
that's cool, Chris.
Yeah, thanks. So the first thing is, why do we need something new? We have existing frameworks. We have PTF, which is already being used in the Dash behavioral model pipeline. It's really well understood and popular in the Sonic and Psi community. But Dash really stretches the limits of current test methodologies. The test cases can be very complex, lots of tables to set up, lots of interdependencies to configure. It even takes a lot of expertise to understand how to create the tables with the proper contents to do meaningful tests. An example of that, an extreme example, is the hero test, which we've been working on for many, many months. And some of that knowledge is going to come out in this framework. The table scales can be very huge. There's a lot of APIs to test. If we want to really test the entire software stack, it makes sense to test it at the different API levels. And we want to be able to test platforms, hardware platforms at line rate. We want to do more than just software virtual testing, and we want to test more than just a packet at a time. We want to test high-speed flows with millions of packets and many, many different IP addresses cycling through, etc. And finally, we're in an era where software developers are really expected to write a lot of their own functional and unit tests. And we're already seeing evidence of that in this project. We don't have a room full of test script writers writing tests for the diligent software engineers. We have to do it all ourselves. So we need efficient, easy, and efficient and easy methods and frameworks, and we want to reduce the barriers so it's not onerous. It's just part of the software development that doesn't seem like a punishment, so to speak. So let me just do a little review of what I call the Dash test maturity stages. I skipped phase 1, which is just early stages in the company's labs. We're really at stage 2, and we're transitioning to stage 3 right now. So stage 2 is you have packet testers, you have some standardized test cases, still using proprietary tools and APIs. In many cases, the DP vendors don't have the full Sonic stack or even the Psi library yet. But we're trying to get to stage 3 where we have Psi and Psi Thrift as the RPC to test the data plane. And I propose that we work our way from the bottom up, and the next set of testing would be using Psi Redis. And that performs an integration of parts of the Sonic stack. And it also verifies the syncd daemon that uses libpsi to control the data plane. That would integrate that. And it would actually verify a lot of the vendor's implementation at that point. And finally, stage 5 would be the full northbound test from GNMI all the way through the Sonic stack on down. And my proposition is we work our way from the bottom up when it comes to the data plane. And likewise, the SDN team would probably work from the top down, where they're starting with the northbound. So this was more or less a development model. I just wanted to restate that because it'll put some things into context. So what, why, what, and when are we doing? So what we're going to do is we're going to contribute this enhanced framework to the GitHub repo. It's already in OCP, and Keysight is sponsoring these enhancements, and PLVision is the experts in this framework, and they're doing the actual development of this. Keysight has been developing a configuration generator for Dash, and my colleague Putrya presented early views of that actually more than a month ago, and we've been using it for many months in various forms to configure real hardware and set them up to run hero test. So this is a proven methodology. It's an algorithmic generator that can be controlled with parameters and to generate very large scale configs. So we're contributing that, and we're actually helping with the integration of that into SideChallenger. And what this will result in is vastly increased developer productivity, where we can focus on the configuration data and not the low-level plumbing details. And this will actually allow us to test multiple APIs with the same test cases by just saying which API to test, and the code and the data configuration don't change. To me, that's a really large improvement here. And as far as when that's happening, it's actually in process, and you're going to get to see, work in progress. It's kind of a checkpoint, and we've got some proof of concept of this actually working with the behavioral model. And so we're looking for feedback, and we want to have, let's say, the first meaningful release of this in October. So I'll pause right now for any questions, and some of the questions I might answer later in the slide deck, but does anyone need any clarification at this point? Okay, I'll keep going. So I'm just going to jump right to the architecture picture that lets people see what we're doing here and get right to the fun stuff. This is the framework that we're working on, and it already exists in a simpler form where it uses the Redis driver. And what we're adding are a number of things. Thrift driver. We're getting some echo. You can mute. Okay, thanks. So the Thrift driver is being added, and that Thrift driver comes directly from the work that Intel did with the Auto Thrift client server framework that we're already using in Dash. So this project actually relies on that heavily. And we have a place in this architecture for a GNMI driver. It's out of scope for this first phase of the project, but I'll talk about that a little bit. And vendors can even implement their own drivers. So if they have an implementation that doesn't have Thrift on it yet, let's say a proprietary gRPC interface or something else, you could write a driver and use this framework and still configure your device while you're on your journey to getting the full Sci implementation. So we think this is a nice platform. This data plane wrapper is something that PLVision already created for their SideChallenger framework, and allows you to control different traffic generators. Not only does it accommodate the familiar SCAPI traffic engine, which is part of PTF, it also will control Snappy API, which I've talked about in the past, and that's a Keysight invention. Snappy is a client library for an open traffic generator interface, and that OTG interface is also open source. It's a model for an abstract traffic generator that can run on different platforms, and we support both software versions like XCSC, which I've talked about in the past, and as part of the Dash test framework already. It will also support hardware traffic generators up to line rate, which today means 800 gigabits per second. So this is paving the way for all scales of testing, both pure virtual as well as true hardware testing. Another core part of this is PyTest, which we're already using in parts of the Dash test framework, the existing one. SideChallenger uses that as well. PyTest is kind of like one evolution beyond unit test, which is part of PTF. And in fact, PyTest can run unit tests, by the way. Here's where the real magic is, I think. The input to this PyTest, there are utilities and drivers that allow you to take data configurations in a declarative form For example, it could be a JSON file or a Python structure, or even a Python library that's generating configuration records on the fly. It will take those, parse those records, and translate them into the appropriate API on the fly. What that means is you can focus on the configuration itself, and it looks just like Psi attributes and tables. Anton will be giving you a look at that, so you'll get a gut feel for it. It will take those data configurations and apply them to the device under test. You don't have to write the code here. It will be done for you. So you can focus on the data. We can actually feed this with our config generator. We've shown you in the past our dash config generator, which was putting out kind of an intermediate form, but we've actually got a version that's generating Psi records appropriate for dash. And those records look like attribute and table entries. So they're very easy to create. You don't have to know the low-level APIs that you get with these drivers. You just focus on the data. And these can be tiny configurations, like just a few tables, or it can be millions of entries. I think it would be only limited by how long you want to wait for these APIs to stream all the configuration to the device. But really, this doesn't have any arbitrary limits on scale. So you could have these configuration items in a file. So it's just a text file. You could have the configuration records right in line in your source code. And Anton will show you examples of these. Or you could write your own code to generate them, however you want. You have test logic like setup, set up the configuration, create some packets, etc. That logic doesn't have to change based on the interface you're using. Furthermore, the logic doesn't have to change if you have different files. You could have as many files as you want for generator configurations and say, I want to apply 10 ACL rules or 10,000. The logic's the same, so you don't have to write lots of test cases. It's actually just parameterized. So I think this will result in a lot of productivity. I'll pause for any questions here. Okay, guess it's going well.
Yep, none for me.
Great. And there'll be plenty of time for Q&A later as well. So I just wanted to recap on this config generator. We talked about it maybe a month ago, and it's continuously being improved, but we've used it in many forms internally. We've been using it to generate proprietary vendor formats for configuring their devices, but we've finally taken this and we're standardizing one of its versions to generate these Psi records. And you can think of it as more or less loops and nested loops that are driven by parameters that can create different scales for the different types of dash configurations. For example, there might be something that generates ACL groups, another one that generates ENIs, route mappings, etc. So these basically contain dash configuration know-how. It's just Python code, very easy to read. And these are all aggregated by what I call an Uber generator that takes all these and creates final aggregate output. So to give you an example, if you were to run something like a full-scale hero test and generate the configuration for that and put it into a JSON file, it's 1.3 gigabytes. That's how much configuration this can generate and save you from having to deal with. So taking this expertise and hard-won knowledge, working with a lot of different people, not just Keysight and PLVision, but many different people from different companies helping us create configurations that make sense. And those configurations also we check and balance with Microsoft to make sure we've interpreted the requirements correctly. So that expertise is embodied in really what amounts to several hundred lines of Python, but done the work and made it easy to use. So this config generator can create text files, which you could use later in some downstream tool, or we can stream it right into this Psi Challenger on the fly. You don't have to generate an intermediate file. These data records can basically just be read like from this data source. Read a record, apply it to the API. So it's not only a standalone application that can generate a text file that you can use and reuse and even transform it to your own internal needs. It can be imported as a Python library and you can use it and we're doing that inside Challenger. So think of this as kind of a dash config wizard. So I just wanted one more time to talk about this diagram, which you've seen pieces of in the past. It shows kind of the relationship between the different layers. We have the GNMI northbound, which is defined by Yang schema. Then we have the Redis server in Sonic Stack, which has an AppDB, which stores a version of this Yang defined schema, but in Redis. The Dash orchestrator converts that and transforms that into ASIC-DB objects, which are basically SCI. You can think of those as SCI records in some form. Those get applied through syncd into the data plane. So that's the transformation this goes through. And based on my current understanding, there's a slight difference between the GNMI schema and the SCI schema. And that's what this orc daemon does. It might make sense to have a modified version that I will call GNMI gen for the time being, that generates GNMI specific records that can then be applied to the GNMI driver. And the reason I point that out is here I show this SCI generator creating records, generating all these outputs. But in reality, we might have a GNMI generator that you can invoke that goes through this stack. And that's something that, we look forward to working with others on. So hopefully that'll spawn future discussions, but we think this framework can be the basis for even testing the SDN work that, Prince and others are working on. So when we get to this stage, we think that this side Challenger with enhancements can be an ideal platform, because we'll be creating these test cases either as data files or generator configurations, these input parameters. There's not that many input parameters. You can tell it how you want ENIs, how many ENIs you want, how many ACL rules you want, etc. And it generates the permutations of all of those. Well, we could use those same data files to define SCI thrift tests, SCI Redis tests, and GNMI tests. Then we have a single source of truth for the DUT configuration and the packets that we're going to send and the logic we use to test that. So that's kind of the vision that we set down, gosh, almost a year ago, and we're finally seeing light at the end of the tunnel. So that's what this meeting's about. So what I'd like to do.
Hey, Chris.
Yeah.
Quick question on the AppDB. So the Dash AppDB schema, are you going to be utilizing that schema in order to convert your Yang coming in from the configuration GNMI Yang into the Dash AppDB, or is it something that we are coming up with a different schema to store all that configuration that is coming into the AppDB?
Well, what I think we would do is we would define test cases that emit some kind of a GNMI configuration itself that would have GNMI configuration objects, and those would get applied to the SDN interface. It's the Dash container here that Microsoft is producing that would actually transform it into AppDB objects. And then it's the orchestrator that would transform those into ASIC objects. So what we're talking about is an external stimulus at the appropriate northbound interface. We will create these configuration objects out of the test cases. And this part of the Sonic stack, I'll call the upper part of Sonic stack, has a job to do, and that's to translate it into ASIC-DB. So we're not purporting to say, but we could make that the scope of the project, or excuse me, not this project, but another project that says, given a GNMI configuration input, let's test that the AppDB contents are correct. That's a possible test you could do, but that's not in scope of this project right now. Does that answer?
Yeah. That answers the question. So in other words, what we are doing is that the transformer from the GNMI Yang to the AppDB is essentially this part of the already defined by Sonic, let's say, this Dash agent that used to be called Bluebird, right? And then now we are basically, we'll have to have that one. So since you mentioned that you plan to complete this one next month. Do we already have the Dash agent available?
Okay, I'll answer that more fully later, but the scope of this project does not include any of the GNMI work. Our project right now. That's a call to action for the community, so to speak. And I'll get into that a little more, but that's out of scope for our effort. We have an architecture here that allows that to fit into this framework, but we're not doing the actual work.
But Prince can talk to that, and
Yeah.
he does have a schedule which is pretty close. Prince?
Yeah, Gerald. I think we are for the GNMI and the northbound part, we are targeting for mid-October. So that's what the current plan is.
Okay, so as part of this project, Keysight and PLVision are not doing a GNMI generator and are not doing a GNMI driver at this time. That's out of scope for our work. What we have is a place for it to fit in, and maybe the community wants to pitch in somehow and come up with a plan to do that together. We're looking for volunteers or sponsor maybe. It's
Yeah,
not in our.
if anybody's on this call that wants to get involved with that, you should contact Chris, because they can't do everything on their own. They need more people helping.
Thanks, Gerald. So as usual, Hannah, you've already read my mind on in these talks, and we've got to part of the call to action, but we'll revisit that at the end. You seem to have a good way of predicting the end of the meeting really well.
Yeah, thank you.
You do. You read my mind every meeting. You
So,
always
yeah,
like you're like the
sorry,
ringer. You're like the guy who knows
yeah.
the right question. It's fun. Actually, I think it's fun.
I don't intend to, but
No,
I
actually,
always
I rather
yes.
enjoy it because it means
Yeah.
I've probably presented the right thing.
Sure.
So
Chris, so just a follow-up, just sorry. So then in that case, right, for the first phase of this project, what would be the trigger for, driving any test cases, for example, right?
Can we table that one and come back to that after the demo?
Sure. We can do
Yeah, I think we want to get through the demo to make sure we do that, because each one of these questions might lead to another fascinating discussion, and I want to give Anton his time, and we can catch up, and we can also, this can be an ongoing discussion, right? This is a work in progress, but we will be creating some test cases in the near future. The quick answer. So with that, I want to turn over to Anton, who is a software architect at PLVision. We've been working together on this, and he'll present his side of things. So go ahead and take the screen if you like.
Yeah, sure. Okay, so hello everyone. So I will switch actually from the nice slides from the Chris and start showing a little bit more code in my IDE. So first of all, I want to show actually the example of the test cases, because Chris showed on the slide that we have number of different possibilities how to write test cases and what to pass. And main format we understand actually is that dash config JSON dash config like format, where we actually describe in the configuration entities what we want, and we can to scale them. So basically that's from the Mircha's demo, when we can set count, start, step, and scale this configuration. So I took it's not the latest one, it's an old one, but that's from the outbound VNet routing configuration. We did it in that expected for the SAGen format, for the SAGen script format. And here we actually defining all input data for the script. And then when we do applying it to the device, we are doing it through the Swift and through the SI. And from that point, actually, we can say that we can write the case directly in the SI. So instead of, for example, doing that configuration and like short one dash format and then like parsing it through the SciGen. Here is the code actually which is doing that. We can write direct Sci calls. So for example, yeah, so here's it, an example. So that's pretty known format, as I understand, like where we have like type, Sci object type, we have keys, we have attributes, we have operation, and we actually do it for all configuration entities we need. So like for the test development, you actually choose what to do. So you can have a high-level format generated, or you can actually use low-level Sci format, because right now this is a separate file, but you can like, this is just a Python dictionary. You can define it inside of the test code and do a single call to the Sci through the selected interface. Like that's kind of up to you. So like separate file, inline file, or what you do call by call, for example. Another example where I can call for create Sci object type and the attributes, and the attributes is something well-known style for the Sci format. Here's the example for the get, completely the same. So like you decide actually according to your need. And yeah, for the hero test, we actually expecting to write it in that format, because then we will translate it where we want, and it will be passed to the SciGen script, which then can scale it, because like if you want really 100,000 of some entities, it will be like too much to write everything in the code, even in the external file. Okay, so that's for the test format. So right now I will be running two test cases, outbound and inbound. Outbound should pass, inbound should fail. So we just will see difference, like to see the output of the test framework. And in addition, I want to show actually the test bed configuration format, because see that both those test cases I will be running on two different setups. And actually, I don't need to do any changes in the code to run it on one or another setup, so they will be fully applicable for both through our wrappers, which also were mentioned on the Chris slide. So let's take a look. So here I have one configuration format for the DPU with Snappy. So see that I have a DPU entity here, and I'm defining, so that's Swift API interface, because there could be, by the way, Redis interface, so which is in place right now, something that we are expecting maybe in future. It's and that's GNMI. So for me, my right now this target BMV2 will be. Next thing is very important stuff. It's data plane. So I'm using Snappy and XAC, because another run I will have with PTF as a data plane. So I'm putting PTF here. This section for me is completely the same. Let's take a look at the pictures, by the way. So like also I wanted to show some difference in the traditional test cases what we have right now, because we have direct calls to the Swift and to the PTF in the test config, and here we kind of decoupled it. So test config is not could be a high-level format, so the one that is used as an input for Sci generator. So that's a separate stuff. Plus we have Sci Challenger for, and we are doing some which contains that wrappers, which allows us to run the same code on the different platforms. And so that's two platforms that I have right now. So the one is with standard PTF based, Scapy based PTF data plane, and another one with Snappy. But see, the test config will be completely the same. So it's just agnostic. It doesn't matter what we have in the data plane, what we have as the API for the dude. We will just select proper client. So right now in my config, I'm using Swift client, but this could be a Redis client, and it select where to connect to the Snappy or like to the Scapy and send traffic with it. Okay, so let's actually go to the real demo. So I'm using Chris scripts for spawning all environment. That's already from some previous demos. So I'm running right now BMV2 model in one window. In another one, I will run size Swift server. Yeah, and here I will run test cases. So I have prepared some comments to copy paste. So here's it. So first of all, I will run XCSC that I'm going to use later. I'm running my container with all environment for the test cases and just entering container. Yeah, so that's to link dash test cases folder. Okay, so actually that's the same folder that we just saw in my VS Code. Okay, so how to run test cases? Pretty simple. So that's PyTest. I'm using verbose mode, and I'm defining setup what I'm going to use. So let's start from the PTF, a standard one, and then I select test cases. I will run so both because I have inbound and outbound. By the way, so each test file contains 3 tests for setting up configuration, sending traffic, and destroying configuration. So total we'll see 6 test cases. Okay, let's go. As I mentioned, 1 will fail. Please pay attention, like 0 packets received, that's for inbound, 5 passed. And also pay attention, so that's actually was a run with a PTF. And now, yeah, so that's output like in the PTF style, something that you used to see in the existing test cases. And right now, I do not change anything in the code. I just replace setup file to the Snappy. And I will run the same test with Snappy. Here it is, like, yet again, same result. 1 failed, 5 passed. Yes, same, like no packets captured, same reason. But you see different output because right now we were using Snappy with and it uses separate methods for running traffic, and therefore we have like a little bit different output. However, the test itself doesn't require any change. Like something that you write, for example, for the model, you can run then on the real hardware. That's the idea of that framework. By the way, so here's it. Like, please, questions.
Hey, Anton, this is Prince here. So how is it different from the current Thrift framework and the test that we have? Like, is it just a replacement of PTF with Snappy, or is there some other value add?
No, so we are not replacing. We building on top because under hood, like still same stuff. Like but what we are adding here, because we are adding abstraction over the DUT API and TG API, so we can use same code of the test case, but run it on the Thrift server, on the Redis server, and future for the GNMI as well. So we do not need to recreate to have like separate test coverage for each level of our verification. So like because for current
I see. So the test configuration can change in future for GNMI, and then run the same test to cover that scenario as well, right?
Yeah.
And the config part will. Okay.
And so, for example, at this moment, what Chris mentioned, so like that commands, sci commands that we have here, so they already could be translated like to the both like to the Thrift or to the Redis. Like you can run if you write this case, for example, in such format, like you already can run same scenario on both platforms. But the real target actually is to have test case in the declarative form for Dash. Then we can translate it like to the not only Swift's Redis, but also to the GNMI or some other custom interface, because the idea here is that every vendor can add own driver if needed, because like, for example, you have test coverage written in that format, and some test vendor can take that coverage, write own driver client, and for example, execute it using some CLI, TDI, or something like that. So that will be completely possible, and to do some even verification on very early stages for them. Because like, anyway, so like we are like building everything around SAI. So that's, in that case, vendors even can verify that if framework produce that, let's say, list of SAI commands, and then with their driver that everything goes well, and they can like validate on very early stages.
So where is this getting translated to the actual SAI configuration? This one that you're highlighting?
Yeah, so like right now, like from that configuration to that, we are translating through the SAI gen. So like, and SAI Challenger itself takes that format of SAI objects and goes to through the client, through the Swift to the Redis, based on what you define in your setup in JSON. So
yeah, there's a real tight mapping between these data records and the actual semantics of each API. You know, it can be done with just clever transformations, right?
Yeah, so actually Chris showed here. Yeah, so that's actually how it goes. So like what I just showed, it's declarative form is related to that block. So also we can have like literal SAI records. So we have some program, maybe some low level to push directly something. And also we have that wrapper. So we have Swift driver, Redis driver, and that's for future. So possible translation to make, because those are just the modules that are loaded dynamically. And but yeah, so that's the idea actually. So you have same test case, and by just redefining everything in the JSON, you can reload from Swift to Redis, and here you go. Like you can run same test case.
So I think my question is, like, we have Intel contributed to the SAI thrift VNet to VNet scenario, right? Can that test be run with this test configuration, or those are two totally independent?
No, so like that's possible. Technically now any problems, so like only like let's say volunteers needed, because see that everything here is built again. So like what Swift is doing, sorry, yeah, SAI PTF test cases are written by Intel, because they're using directly Swift, and they're using PTF. Okay, and all that parts are actually part of that framework. So that's only a technical question, like how to wrap them inside of that picture, because that's possible. We already using Swift, and the question, okay, so let's if we do not want to have high-level format, we can do low-level calls like introduce. That's one thing that we need to adopt here. And another is actually PTF, you don't need to do anything. So let's take a look at in that test code, my traffic code. So that's just not almost that copy paste from the GitHub. So it's completely the same. You don't need to do anything. It's the same what we have at this moment. So in future, for the hardware traffic generator, we might have some specific functions that are not possible to run with PTF, but like existing functions from the PTF wall could be launched through the Ixia, so that's no problem to transform them. So from that point of view, test completely the same. We need only to create proper PyTest fixtures to run existing code.
Yeah, I'll touch on your question also, Prince, in a moment when I kind of wrap this up. I'll circle back and I'm going to almost turn the question on its head, and you'll see why I say that in a moment. Anton, is there anything else you wanted to show before I go to some of the conclusion slides?
Also, like I'm done.
I have a question for Anton or Chris.
Mhm.
I thought that, when using the Redis, we are writing the entry directly into the ASIC DB, which means we need to create an entry in a format that ASIC DB expects. And from that down, it looks like it's Sonic on top. And, first of all, it uses portion of Sonic right here using the ASIC DB. And that using the pub sub mechanism, just like how Sonic would you normally run, the syncd will get a notification and then call the corresponding hardware APIs, right, using the Psi API implementation. So are we writing the entry as expected in the format that's expected in the ASIC DB using this framework?
Yeah. So like in the wrappers itself, we are transforming to the Redis-like format. I have to say that we started from Redis-like format, but have to shrink it because to avoid multiple wrapping layers. Like that's why we used that short without wait, colon, and so on.
The simple answer is these test cases, the form of the duck configuration is done in a way that can be translated directly into Redis CRUD operations or thrift API calls. That was the whole point of this framework, right? The data itself is it contains Psi objects, but they're abstracted. And PLVision this is already in play. This is what Psi Challenger already does. It creates Redis entries in the appropriate format. So this is like over a year old, that part of it. We've added the thrift and these other concepts to this, right? So yes, if the vendor has implemented this and has this all running on their device, even without the rest of Sonic, this test can be done.
It will be really great to have this, framework that can generate large amounts of configuration, and it will be really good to use it with the thrift.
Yeah, both. So thanks for all the questions. I know this is a lot and a big gulp. That's why we wanted to give a sneak preview, because we'll lay the groundwork for future as well. So let's just talk about some of the deliverables we're hoping to do next month sometime. This will be upstreamed. So Psi Challenger is already part of OCP. This will just be a pull request. And PLVision's been the maintainer of that anyway since they created it. And then the integration into Dash, it's going to be a pull request so that this gets pulled into Dash as a Git submodule. It creates containers for running all the client software. So it'll just be like the current Dash BMV2 pipeline test framework. There'll be a client container that has everything in it you need to run tests. We'll have a few initial test cases. We've been focusing on the framework and not the scale of the tests. We hope the test cases are easy enough to mimic that people can start writing their own as well. That's always the unspoken assumption, is we're trying to plant seeds here to empower people to do more of this themselves. We'll be verifying these against the behavioral model using software traffic generators. And at some point in the future, when vendors have a device with Psi support, meaning, concretely give us a DPU card with a thrift server running on it at port 9092, we'll start playing with it with hardware as well. So that's, a TBD exercise, but we really are looking forward to that. And then other possibilities. One is this GNMI, which Hanif already planted the seeds for that discussion, but we need to come up with formats, generators, and API drivers and test cases. And we don't have the manpower right now to do this ourselves, so we're looking for people to volunteer. Or if someone wants to sponsor our wonderful friends at PLVision to do this, I'm sure they'd be happy to. But this is I think this would be a fun project. And then there's also the possibility of taking some of this work and porting it back into PTF. So this is where I wanted to turn the question on its head a bit that Prince asked. You know, can we still use PTF tests? I'll jump to this one first. You could use SciChallenger as a single pane of glass to run existing PTF cases just to make a simpler user experience and get a few other benefits. But there's some work to be done, and that's not in the scope of our engagement here, but it can be done. And the other is take some of this know-how, since it's all open source, and port it back into PTF. There's no reason why PTF couldn't be enhanced. For example, if you say run this config generator or take this JSON file, feed it into this parser and driver, and configure your device with SciThrift. So in a way, we're getting 1 + 1 = 3 out of this project, because we not only are taking all the good stuff in PTF today and the SciThrift server framework and coming up with this new platform. This platform can then be used to sort of pay it forward back to PTF. There's no reason why they couldn't be done. It's just plumbing. It's just software. There's no high tech here involved. It's just work, and it probably can be done. And I think it'd be kind of exciting. I did a POC a 1.5 years ago, putting a snappy test into a PTF test. You know, I just did that at a P4 workshop as a POC. So it can be done. There are some caveats with PTF in that it sort of assumes the data plane is SCAPI and it's always there. So we might want to write new test cases in a little more clever way to be able to work this way, but it can be done. So PTF can get kind of like a vitamin shot from this project if we want. And then finally, do we want to make BMV2, do we want to make a virtual version of Sonic running BMV2? I think that's a large scale project. It means we'd have to have a syncd integrated with BMV2 and the libsci. And you might even raise questions, you know, do we need underlay, etc. But the idea is, do we want a full software implementation of Dash that we run in the cloud for CI/CD testing? There is work to be done, and I think that could be, you know, future discussion. So that's some future possibilities. And finally, I guess the call to action on this is, we'd like some feedback today, if possible, or anytime. We probably need to close some gaps in the current BMV2 to run more meaningful test cases. We really want to run stateful processing or other types of tests. There may be some things to finish before we can do those test cases. So I'm hoping some of this can filter into the behavioral model working group, and we can maybe agree on some kind of a goal saying, okay, we want this amount of functionality so we can start writing these test cases. Because what we really want is to have test cases that we can then apply on hardware and show that they match both in software and hardware. Who wants to work on GNMI? And then we'd like to help writing test cases. So we're hoping once this is released, it'll be so easy that people will just do this every time they add a feature.
Yep, I think those are the big needs right there, Chris. Thank you.
Okay, so that's our presentation. Any other questions or feedback? We'll circle back in a month or month and a half with the next release of this, the release of it.
If someone would want to participate and, you know, do test cases and have questions or anything, could they reach out? Should they reach out during this meeting or individually, or?
Anytime, anyway, you can email me, Teams, bring it up in a meeting.
PRs, GitHub, PRs.
Yeah.
We have lots
I would
of
like Christina for a formal list of work items, and then where we can see volunteers going against. I don't want to see 2 weeks from now we don't have any volunteers. So I think we need to create the list of work, prioritize that, make sure we're aligned with that, and then start putting names who can volunteer and help with this, because I don't want this. This is super, super important stuff. This is quality, and we want quality built into Dash. And if we don't get volunteers, it's really, you know, we're not going to have the quality that we want. And so it's as important as designing, you know, the Dash orchestration agent. I mean, it's along the similar lines. Testing is job number one, quality. Remember, Dash can only output a golden image of a behavioral model. We need to know that it's correct. And then, all the hardware vendors will get all the benefit of being able to run those same tests against their hardware. And so that's like huge, right? It's a huge benefit to the community overall. So we do need to formalize the list, I think. I think that's the job number one, what needs to get done. Make sure that Prince and others on this call agree that, this is the, right strategy, this is what we should move forward. And then let's get volunteers and get people working in this area.
Thanks, Gerald, for the support. So I want to thank PLVision for all the great work on this project to date, and also just having something like Site Challenger, which was, all ready to be the framework for this. Once I saw their presentation, I had that in the back of my mind for the last year. And now we're finally seeing the exciting stuff running. It's gratifying. And also, we've been working, one-on-one with different DPU vendors, which I won't get into specifics, but a lot of their knowledge and know-how has gone into creating like the generator and verifying it actually configures real hardware and does real tests. And Microsoft has been interacting with us a lot as reality check on all this config generator. So we appreciate all the help. A lot of hands went into this, by the way. Some of them behind the scenes. So thanks everyone.
Yeah, Chris, and you and I can create a list of items offline. Yeah. Well, I'm going to stop the recording. Thank you so much for the demo today. Out